Hey there. This is assignment 78 in our systems unit, and its focus is on elimination and graphing as a method for solving systems. Um, so, uh, I would love it if you did this problem as bell work um, three different ways. I would like you to solve this with substitution first. And then I would like you to solve this with elimination. And then I'd like you to solve this with, I think I want you to solve it with elimination. And I'd like you to solve it graphically. Y minus x equals 4. Okay, so give it a try. Come back when you're ready. Okay, so substitution. I solve one of the equations for one of the variables, y equals x plus 4. I take that and plug it into the other equation. So x squared plus x plus 4 squared equals 8. X squared plus x squared plus 8x plus 16 equals 8. I'm going to subtract 8 from both sides, and I'm going to combine like terms. So I've got 2x squared plus 8x plus 8 equals 0. And before I factor this as a trinomial, I'm going to do the GCF and pull out the 2. X squared plus 4x plus 4. And I see a perfect square trinomial here. It factors as x plus 2 times x plus 2. So I know there's just x equals negative 2 as a solution to this. And I need to list my answer as an ordered pair. I've got the x value. I can certainly plug in here. But I like this one because this one says y equals. And exactly what I'm looking for is y. So negative 2 plus 4 is 2. So y equals 2. Again, do not write your answer that way. I want you acknowledging that the solution is a point of intersection on a graph. Okay? Okay. So that was substitution, and it wasn't so bad. What about elimination? Well, yeah, that kind of sucks. What if I subtracted one equation from the other? I wonder what happens then. I'm actually wondering. I've never done this before. Um, and I just see that I'm going to have x squared minus a minus x. And I'm going to have y squared minus y. And then I'm going to have 8 minus 4. Well, that looks a whole lot like it's set up for turning into a new and different circle. Problem is I still have two variables. So yeah, no, that didn't work for me. So I don't think I'm doing that. What if I took this equation and actually did that square? Y minus x squared equals 4 squared. Squaring both sides of the equation, not each piece. So we have y squared minus 2xy plus x squared equals 16. Okay, so I can replace this equation with this one. And now I've got x squared plus y squared equals 8. And then here I've got x squared minus 2xy plus y squared equals 16. And I can do elimination now. X squared minus x squared, they go. Y squared minus y squared, they go. 8 minus 16 is negative 8. And I'm left with this. I'm subtracting a minus 2y, a 2xy. So minus a minus is going to be plus 2xy. And I can certainly divide both sides by 2. Xy equals negative 4. But I still don't have a solution. And in fact, I'd have to now divide and say, okay, wherever I see x, I can replace it with negative 4 over y. Ugh. Yeah, no, I take it back. I definitely don't want to do this one with elimination. If you saw a nicer, easier way to do this one with elimination, let me know. Graphically, I know that I'm looking at a circle whose radius is the square root of 8, which is 2 root 2. And the square root of 8 is a little less than the square root of 9. So I know that 3 would be over here and 2 would be over here. And this point will be the square root of 8. I also have here the equation of the line y equals x plus 4. Now, x plus 4, that's a positive slope and a positive y-intercept. And this y-intercept is bigger than this y-intercept. This is the square root of 16. This is the square root of 8. So I'm only going to get one point of intersection because my line passes through there and has a positive slope. So I've got something like that. And that point, definitely a negative x and a positive y, makes a lot of sense for that solution I got with substitution. I do see that, while I can determine the quadrant for my solution, I don't really have a comfortable understanding to say, yes, that's the ordered pair negative 2, 2. As some people say that when they use graph paper, they can get that solution. And yeah, sometimes I can too. But I remember one time as a math teacher, a number of years ago, I had a piece of paper, a graph paper, and I had my students doing some math on it, calculating slope. And yeah, it turned out that the boxes weren't squares. They were slightly longer in one dimension than the other, and as a result, our slopes weren't coming out correctly. And so, yeah, even graph paper can occasionally have its faults. So I think I'm going to say I like graphing as a way to pre-visualize, to hypothesize what sort of situation I have, not to actually find the points of intersection. I mean, I guess I could take out my graphing calculator and graph each of these equations. The problem though is my calculator always demands y equals form. And so here, I can get there pretty quick by having x plus 4, I add x to both sides. But with this one, I'm going to have y squared equals 8 minus x squared. And then when I take the square root, I get y equals plus or minus square root of 8 minus x squared. Oh, blork. So I've got to put that one into y1, and that one into y2, and that one into y3 to find these points of this point of intersection. Okay? So yeah, I could do this on my graphing calculator, but yeah, I'm keen generally not to. All right, let's go back then and take a second look. Let's go back then and take a second look at solving just with elimination. Remember, with elimination, we want to get one of the coefficients either to be the same or opposite each other from one equation to the next. So I could multiply this top equation by 4, and then these would be the same. Or I could multiply the top equation by negative 4, and then these would be opposites. Remember, if the coefficients are the same, I subtract. And if one's positive, one's negative, then you want to be adding. But I see, like you see, yeah, I heard you. We could just add these equations together and cancel out the y's. So I'm going to have 10x equals 5. This next step is terribly important for some of you who are really, really smart and really, really fast, because I get a lot of people who look at this and don't go any further except to say x equals 2, and now they're wrong. It might be worth the time to actually do that, because then you'll see that x is 1/2. We're not done. We know we're not done because I need an ordered pair. So if I plug that 1/2 in up here or in here, I'll be able to solve for y. So 8 times 1/2 plus 3y equals 1. 4 plus 3y equals 1. 3y equals -3. And so y equals -1. So my solution then is going to be at 1/2 -1. And I appreciate only one solution because I'm dealing with some linear equations. And I can't, if I'm dealing with linear equations, get 2 points of intersection, at least not in the Euclidean universe that we live in. Okay, so will you solve this one? 3x plus 2y equals 10. All right, so did you get rid of x's? Did you get rid of y's? In my experience, most students want to get rid of the x's because they don't want to deal with 7. So if neither of these are the same or opposites, then, I'm going to multiply. I could do this simply by multiplying everything here by 3/2, because then the 2's would cancel and I'd have 3x and 3x. Yeah, it's the rare student who wants to multiply the row by a fraction. Instead, they want to multiply each row by a different thing. So I'm going to have 6x minus 21y equals -30. And I'm going to have 6x plus 4y equals 20. And because these coefficients are the same, I want to subtract. 6x minus 6x minus 21y minus 4y is minus 25y. And then minus 30 minus 20 is minus 50. Can I just say that that work of doing that subtraction, so many people make a sign mistake. So I'm going to go through and just make sure I did it correctly. 6x minus 6x, gone. Minus 21 minus 4, nice. Minus 30 minus 20, nice. And again, don't do this in your head. Oh, there's such a good chance you'll get it wrong if you just try and do it in your head. -50 divided by -25 is +2. Am I done? No. Just because I know that y is equal to +2 doesn't mean I'm done. I still need to find out the x part of this solution. I'm going to take this y and plug it in either here or here. So I'm going to have 3x plus 2 times 2 equals 10. 3x plus 4 equals 10. 3x equals 6. X equals 2. Ta-da! The ordered pair 2, 2 is my solution. Nice. What about this one? X minus 3y equals 18, and negative x plus 3y equals 12. Will you find the solution? Yeah, that one went pretty fast, didn't it? Because if you just add x plus negative x and minus 3 plus 3, you end up with a big old 0 over there. 18 plus 12, 30. 0 equals 30. What does that mean? Correct. This is no solution. These lines never intersect, which means these lines are parallel. Because parallel lines won't intersect. All my other lines will intersect someplace at some time. Unless, of course, the lines sit on top of each other. And that's that parametric solution. They have the same slope, but they also have the same y-intercept. Okay, so there was that one. And can you do this one for me? 4x minus y equals -6. -4/3 x plus 1/3 y equals 2. Yeah, and many of you are like, Kukla, you're so mean. But think, what is it we've been saying since August? When you have an equation that has fractions, what should you do first? Yeah, you should multiply everywhere by the least common denominator. And that's 3. So 4x minus y equals negative 6. And then when I multiply by 3, those cancel. I have negative 4x. I multiply by 3, those cancel. I have positive y. And I multiply by 3, and I have 6. And lo and behold, I get 0 equals 0. Am I done? Do I write infinite solutions? Not unless you want me to mark it wrong. I need a parametric solution. So how is it that we wrote that parametric solution? I seem to recall 2 steps. 1, set x equal to a. And 2, I want to plug x equals a into one equation and solve for the other variable. Okay, so I've got this equation, and I'm plugging in x equals a. So I've got 4a minus y equals negative 6. And then I'm asked to solve for the other variable. Well, the other variable is y. I want to solve this equation for y. I can subtract 4a from both sides. Negative y equals minus 4a minus 6. And then if I divide everywhere by negative 1, I get y equals 4a plus 6. And so my parametric solution then is going to be a, because that's what x is. X equals a. And my y value is 4a plus 6. And that's my parametric solution. I think you should do another one of those, don't you? So 2x plus 5y equals 1, and x plus 5 halves y equals 1/2. Please solve that system. Hey, welcome back, everyone. So, did you use elimination? Did you use substitution? What'd you do? I'm going to use elimination, and I'm going to multiply everywhere by 2 in this row to clear out the fractions. So 2 times x, and 2 times 5 halves, the 2's cancel, leaving me 5y, and 2 times 1/2 is 1. Mirabile dictu, marvelous to behold. Look what happens. 0 equals 0. So yeah, this is more practice with parametric. So what's the parametric solution look like? If you haven't already, pause the video and try and write up the parametric solution, please. Okay, welcome back. So remember, x equals a, and we plug x equals a into either equation. I don't want to play with the fraction. So I'm going to plug that in there. I'm going to have 2a plus 5y equals 1. And then I was directed, once I plug that in, to solve for y. So I'm going to have 5y equals 1 minus 2a, or y equals 1 minus 2a over 5. Now, I will say that most people, most students like doing this. Most test writers like saying that's y equals 1/5 minus 2/5 a, or even y equals minus 2/5 a plus 1/5. Whichever method you use, this one, I don't care, they're all the same. I do want to see, though, a, comma, one of these 3 solutions. Negative 2/5 a plus 1/5, I believe, is what your book would use. But if you wrote that on a quiz, I wouldn't mark that wrong. So there's our parametric solution. Woohoo! All right, let's just do 2 more to wrap this up, and then I want you to think about writing your own system. All right, I'm telling you now so you can start thinking about that. 6x minus 3y equals 1. 4x minus 2y equals 7. Will you please solve this system? And I would use elimination, but that's me. Hey, welcome back. How'd it go? What did you see? What did you discover? So my guess is that you multiplied the bottom row by 3 and the top row by 2. Um, so I think that's what I'm going to do. 6x minus 3y equals 1. And 3 on the bottom, which is 4x minus 2y equals 7. So when I distribute, I'm going to get 12x minus 6y equals 2. And I'm going to get 12x minus 6y equals 21. That gives me 0 equals, I'm subtracting here, negative 19. These numbers are not equal. So what does that mean? No solution. No solution. These lines are actually parallel. If I solve them both in slope-intercept form, y equals mx plus b, I would see that they would not only have the same slope, but I would also see that they have different y-intercepts. And so I know that this is going to be no solution. These lines with the same slope and different y-intercepts will never intersect. Okay, last. 3x minus 8y equals 1. 6x plus 2y equals 1. Please solve that system. Okay, welcome back. I think I'm going to multiply the top row by 2. 6x minus 16y equals 2. 6x plus 2y equals 1. And subtract. 6x minus 6x, cancel. Why subtract and not add? Because these coefficients are the same. If these coefficients were opposites, one positive, one negative, this would be addition. Okay, so those cancel. Minus 16 minus 2 is minus 18y, and 2 minus 1 is 1. And so I get y equals negative 1 over 18. Ew, that doesn't seem right. And it's not, because as I go and look back at the original problem, that's an 11. So that's supposed to be an 11. So 2 minus 11 is supposed to be negative 9. And now, oh, that makes a little more sense. I get 1/2. So if y is 1/2, am I done? No. I need to plug this back in to one of those equations. 6x plus 2 times 1/2 equals 11. 6x plus 1 equals 11. 6x equals 10. And so x equals 10 over 6 or 5/3. Please make sure you write this as an ordered pair so that we remember that solutions represent points of intersections on graphs. So I'd kind of like you to write your own system. And I'd kind of like you to solve your own system. And if you watch this and hear me say that, and then you do it, email it to me, and I will put it in as extra credit. All right. Other than that, have a wonderful day, everyone, and let me know how I can help. Take care.